Hey everybody. So we're going to go through method 2 of how to find the limiting reagent. We're going to do a slightly different example, but with fairly similar compounds. This method was one of the ones that I used to use when I was in high school, just converting. I found it easier to convert with this way. Basically the idea of this second method, so basically the idea of method 2 is you go from grams of one reactant to grams of the other reactant. So the idea then here is we're going to compare the amount of grams that are required with the amount of grams that we've been actually given. I like this method easier. It takes one less step than the previous method, but if you do not understand what you're doing, I would highly recommend doing version number 1 because that one's a lot easier to compare and contrast and say, this number of moles is smaller, meaning that one is my limiting reagent. With this method, yes, it requires less steps, but it also requires you to have a greater understanding to use effectively those less steps. So as with every question ever in chemistry, we're going to start with the balanced chemical equation. And what we're told in the question is that calcium chloride reacts with sodium hydroxide to produce calcium hydroxide and sodium chloride. Okay, so we're told that calcium has a +2 charge, chloride has a -1 charge, so it'll look like this. Reacts with sodium hydroxide, sodium has a +1 charge, hydroxide has a -1 charge. To produce calcium hydroxide, as we said, calcium has a +2 charge, and hydroxide has a -1 charge, and we're also producing sodium chloride, sodium with a +1, chlorine with a -1. That then is the starting point for our balanced chemical reaction. Next thing that we need to do is add in balancing coefficients. And so we could see here that I got two OHs here, 2 hydroxides, and over on the left I have 2 chlorides. So what I'll need to do first is let's try balancing these hydroxides. I have 2 of them here. Well, let's make 2 of them there. I now have 2 sodiums. I have 2 hydroxides. I also have 2 chlorides, so I can balance all of those out by putting a 2 in front of the NaCl. Now, what I've done is I've compiled all of the steps into a smaller clustered area because I want to be able to do all of my work in one string of time sign lines. That's the end goal of what I want to be able to do with method 2. So I'm going to start with calcium chloride, and I'm going to start with the 75 grams of calcium chloride that I had. So I have 75 grams of calcium chloride, and I'm going to then just use my skills from stoichiometry to go from grams of calcium chloride. So I want to go from grams of calcium chloride, and I want to convert to grams of sodium hydroxide. Now what that will tell me is how many grams of sodium hydroxide are required to react with 75 grams of CaCl2. We'll do the work and I'll show you what I mean. So we have grams of CaCl2. I want to get out of grams of CaCl2 and into moles of CaCl2. So with the calcium, calcium has a mass of 40.08 as shown on the left over here. Chloride, we saw that there were 2 of them, so we have 35.45. So we have a total molar mass of 110.98. Total molar mass of 110.98 grams. And that will get us into moles of CaCl2. So now that we're in moles of CaCl2, what I want to do is use my stoichiometry skills and convert from moles of CaCl2. I actually don't want to use 1 here. I want to convert from moles of CaCl2 into moles of my other reactant. So I want to convert into moles of this 2NaOH. So I want to get into moles of NaOH. And what I'm going to do here, as with stoich, is I'm going to plug in the balancing coefficients. So we know that from this reaction, it requires 1 mole of CaCl2 and 2 moles of NaOH. Now that I'm in moles of NaOH, I'm just simply going to go into grams of NaOH. Going back to my periodic table, sodium has a mass of 22.99. Oxygen has a mass of 16, and hydrogen has a mass of 1.1. Oop, that's 10.01. 1.01. So we find that the total molar mass of NaOH is 40 grams of NaOH. So we're going to plug this all into our calculator. We're going to take 75 divided by 110.98 times 2 times 40. And what we would find then is that that is equal to 54.1 grams of NaOH. So now we have reached the end point of this question. We have been told that for 75 grams of CaCl2, you only need 54.1 grams of NaOH. But in the question, we were told that we have 127 grams. So what that means is that I only need 54 grams to react with all 75 grams of CaCl2, meaning I have an excess, or I have extra, of the 127 grams of sodium hydroxide. I have more than I actually need of this sodium hydroxide. So what I would say then is I would put a big old capital E below this, and I would circle it because that tells me that that is an excess. And then near the CaCl2, I would say that this then is my limiting reagent, because in order to have this reaction happen, I would use all 75 grams of CaCl2, but I would only use 54.1 grams of sodium hydroxide, even though I have 127 grams of them. So that was like when we were looking at our Big Mac example. And yes, I have bonus cheese, bonus buns, bonus patties, but I only have one pickle. So I am limited by the number of pickles I have. Same as this question here, I am limited by the amount of calcium chloride that I have. If we were to start this reaction instead with the NaOH, if we were to start this reaction with the 127 grams of NaOH, we would get a number that was larger than 75 grams. And because that number would be larger, we would know that, okay, I don't even have that much. This calcium chloride must be what's limiting the reaction, not the sodium hydroxide. So that's method 2 of how to find out what is the limiting reagent.